Okay, so we're going to start to develop just the first quadrant in the unit circle. And I'm going to show you where those values came from in that unit circle. Okay? Now, we have been given, say, a point, a one coordinate point, and you had to figure out what sine or cosine is of that specific point. Okay? Or you were given an angle. In this case, this is going to be a special right triangle. So it would be the 30 degrees. When we just looked at that unit circle, it was that very first line in the first quadrant. Okay? This was that yellow line right here. That's our 30-degree angle. Okay? Let's just write in what those ratios are if it's just a regular 30, 60, 90. So a 30, 60, 90 is 1, 2, square root of 3. Correct? Across from the 30 is always the 1. Okay, so we have 1, 2, square root of 3. So across from the 30 is 1. Where does the 2 go? The hypotenuse. And square root of 3 is across from the 6. Correct? So that's our ratios for a 30, 60, 90. Okay, and right now we're looking at the 30 degrees, right? But if I want to take this, here's my unit circle. It would go right here. I told you that the radius of the unit circle is always what? 1, correct? Right now, what is the radius? What is the radius right now? 2. My radius is my hypotenuse. This is my radius, correct? So if we're going to make this fit into the unit circle, then I need that radius to be 1. Well, how can I take 2 and change it to 1? How can I do that? Divide by 2, okay? We can only scale things by multiplying by something or dividing by something, okay? You can't add or subtract. That won't work. And so if we divide by 2, then my radius will be 1, correct? But if I divide that one side by 2, what else do I have to do? I have to divide all the sides by 2 so that it scales the same. Okay? So now my ratio is square root of 3 over 2 and 1/2. And my radius is just 1. Everybody see that? Now that works in the unit circle, because the unit circle, it doesn't matter what the legs are, but the radius has to be 1. Now, let me ask you this. Is this my x-coordinate or my y-coordinate? Okay, that's my x-coordinate. And what's this? That's my y-coordinate, correct? So my x-coordinate is this, and my y-coordinate is this. Correct? Okay. If I asked you to tell me sine of 30 degrees using that triangle right now, sine is what over what? Opposite over hypotenuse. What's my hypotenuse? My hypotenuse is 1, correct? So the sine of 30 degrees ends up just being the opposite, which is 1/2, over my hypotenuse, which is 1. Everybody see that? So the sine is 1/2. Right? Stay with me. 1/2 is the same thing as my y value, correct? So that is the same thing as my y value. Okay? What I'm doing right now is I'm developing what this point is right here in the coordinate plane. What do we just find the y value to be? 1/2. This y value is 1/2. Everybody with me? Let's do cosine. We're not going to do tangent. We're only going to do sine and cosine. And so cosine of 30 degrees is what over what? Adjacent over hypotenuse. And my hypotenuse is just 1, so it ends up being just the adjacent. What's the adjacent? Square root of 3 over 2, which is what value? That is my x value. So x is the square root of 3 over 2. So this point on the coordinate plane for a 30-degree angle, the coordinates of that point are the square root of 3 over 2, comma, 1/2. Right? Okay? We just found that. If I would go back to that unit circle that I showed you, that's what you would see. The points are right there. And this is the reason why. Okay? So what we can say is, if I say the sine of 30 degrees equals 1/2, and that's the same thing as y, then we can say sine is y. We can say cosine is x. So these values right here ends up being x, it's xy, right? But that's the same thing as cosine sine. So cosine of 30 degrees is my x value, which is square root of 3 over 2. Sine of 30 degrees is my y value, which is 1/2. So if we were looking at this, and you had the unit circle in front of you, without all the rest of the stuff, if you knew what this point was, and that's 30 degrees, and I asked you, what is cosine of 30 degrees? All you'd have to do is look up here and tell me that's square root of 3 over 2. Because in the unit circle, the radius is 1, your hypotenuse is 1. So when you do cosine, that's the opposite, that is my y value over 1. Sine is the adjacent, that is my x value over 1. Y'all with me? Let's go down and let's do, I'm going to jump to, let's do the 60-degree one. So in that first quadrant, there's a 30-degree angle, a 45-degree angle, and a 60-degree angle. So let's figure out what these values are right here. What are the coordinates of that point, using the same logic that we used a while ago. Now, you're not going to have to do this every time. I'm going to give you a unit circle with all these values on it. Okay? But you need to understand where they come from. That cosine is your x value, sine is your y value. Okay? Now that's a 60-degree angle. So the first thing we're going to do is write in our ratio, and then we're going to adjust it to fit the unit circle. Okay? So that's a 30, 60, 90, correct? The ratios for a 30, 60, 90 are 1, 2, square root of 3, correct? So now we're looking at a 60-degree angle. My 30-degree angle is at the top right here, correct? That's my 30-degree angle. So the 1 always goes directly across from the 30-degree angle. So that is here. Where does 2 go? The hypotenuse. And across from the 60-degree is square root of 3. Now we need to adjust it to fit the unit circle. So what do? Divide everything by 2, because your hypotenuse, that is the only thing. It has to be 1. In the unit circle, the radius is 1. So your hypotenuse is 1. So in order to make it be 1, we take everything and we divide it by 2. Now it becomes 1. That becomes 1/2, and that becomes the square root of 3 over 2. Now it fits my unit circle, and we're trying to figure out what are the coordinates of that point. So let's do sine of 60 degrees. Sine is opposite over hypotenuse. What is the opposite of 60 degrees? What's directly across from 60 degrees? Square root of 3 over 2. And my hypotenuse is just 1, so I don't need to put that over 1. You understand? Now remember, this is my x value, and this is my y value. So square root of 3 over 2, that's the same thing as my y value. So the sine of 60 is square root of 3 over 2. And at that angle, your y coordinate is square root of 3 over 2. Now, cosine of 60 degrees is adjacent over hypotenuse. What value is adjacent to 60 degrees? 1/2. And that's the same thing as what? My x value. So 1/2. So the coordinates of this point here are 1/2 and square root of 3 over 2. Well, since x is the same thing as cosine, if I asked you what is the cosine of 60 degrees, you would just look at this and say square root of 3 over 2. If I asked you what is the sine, cosine is 1/2, sine is square root of 3 over 2. Okay, it's reversed. 30 degrees and 60 degrees are the same values, they're just reversed. Okay, so the trickiest part in looking at the unit circle is remembering that those coordinates go cosine sine. Instead of x, y, it's cosine sine. Okay? It's like handing you the information for all of those angles in one drawing without you having to draw a right triangle every single time to figure it out. Okay? Any questions? So remember, x is the cosine, y is the sine. So let's go do the 45-degree one. That's the last of the special angles. This would be that middle angle in that first quadrant. Okay, it was 30 degrees and 45 degrees and 60 degrees. My ratios for a 45, 45, 90 is what? 1, 1, square root of 2. Okay? So 1, 1, square root of 2. Now what's the next step? We have to adjust it to fit the unit circle. So my hypotenuse needs to be 1. So how do I do that? Anything divided by itself is equal to 1. So we have the square root of 2, so I have to divide by the square root of 2. Okay? So we divide by the square root of 2, and that equals 1. But then we have to divide everything by the square root of 2. Before we can move a little forward, what's the problem with those? The legs. Very good. Cannot have a square in the denominator. So we have to just fix that. And you're only going to have to fix this once. You're not going to have to fix it every single time. But when I fix it, how do I fix it? Very good. Multiply the top and bottom by the square root of 2. So you end up being square root of 2 over what? 2. Okay? And this is exactly the same thing. If it's a 45, 45, 90, your legs are the same. So each leg is square root of 2 over 2. And my hypotenuse is just 1. So these are my values. Hypotenuse, leg, leg. This one down here is what value? X or Y? At the bottom, that's my X value. And at the top right here is my what? Good, is my Y value. Okay, so let's go. Now this fits into my unit circle. And we're going to name what the coordinates of this is. So, sine of 45 degrees, that's opposite over hypotenuse. What is the opposite? Square root of 2 over 2. And that's the same thing as what value? A Y value. Cosine of 45 degrees is what? adjacent over hypotenuse, which is the same thing, right? Sine and cosine are the same for 45 degrees. Square root of 2 over 2, which is my x value. So what are my coordinates up here? And square root of 2 over 2. Okay. All right, so let's look at, don't copy this down, just pay attention. Let's look at this right here, and it might be kind of difficult for you. Okay, so I just made this bigger. So this is just the first quadrant of the unit circle, what we just did, okay? What we just did, we took, if I made this 30-degree angle, this is my 30-degree angle, okay? Here's my little right triangle. We found these coordinates to be the square root of 3 over 2 and 1/2. We just developed that, right? Right? And then here's my 45-degree angle, and we found those coordinates to be square root of 2 over 2 and square root of 2 over 2. And then for my 60-degree, it's 1/2 and square root of 3 over 2. Okay? That's what we just found, right? Now, I want to show you a number pattern. First of all, what are all the denominators? All the denominators are 2. So that's your first number pattern. They're all 2. Another number pattern is all of the tops, you can say, are the square root. Square root something over 2. Square root something over 2. Except that, what's the square root of 1? Just 1, right? So it works like this. For your x values, you start at the top, it goes square root of 1, square root of 2, square root of 3. And then it goes backwards. Square root of 3, square root of 2, square root of 1. Okay? So there's a number pattern that follows. Okay? So that'll be what you'll have to memorize to draw a quick unit circle. Now, if I take this same, remember we did reference angles? Okay? So if I drew an angle over here, and this was a 30-degree reference angle, that sine and cosine will be the same values. Okay, sine of 30 degrees and cosine of 30 degrees don't change. The only thing that changes is, what do you think is the only thing that changes? The signs of the coordinates. That's it. So it's still going to be the square root of 3 over 2 and 1/2. Except that, what's different? It's going to be negative square root of 3 over 2. That is the only thing that changes in every quadrant. All of those values are the same, even if I came down here. If this is 30 degrees, my coordinates here are still going to be the same. Square root of 3 over 2, comma, 1/2. But what's going to be different? They're both going to be negative. They're both going to be negative. Okay? And down here, this is another 30-degree reference angle. So this is also going to be square root of 3 over 2 and 1/2. But what's different? The 1/2 is negative. Okay? So, and that's the same thing for the 45 and the 60. Everybody understand? So, we developed how to get all of these values using this right triangle, and then using the right triangle for the 45 and the right triangle for the 60. And we found that x is always cosine of that angle. Cosine of whatever that angle equals your x value. Sine of whatever that angle is equals your y value. So just looking at this, if I asked you, what is cosine of 45 degrees? Square root of 2 over 2. What is sine of 60 degrees? Square root of 3 over 2. It goes cosine, sine. Your coordinates are represented by cosine of that angle, comma sine of that angle. Okay? So what is cosine of 0 degrees? where's 0 degrees? 0 degrees is right here. The coordinates of that are 1, 0. So what is cosine of 0 degrees? 1. What is sine of 0 degrees? 0. What is sine of 90 degrees? Sine is, okay, here's 90 degrees. Cosine, sine. So sine of 90 degrees is 1. Cosine of 90 degrees is 0. Are you all with me? That's a quick way to show you all of those values. Okay? So I showed you this angle, this 150 degree angle. The reference angle is 30 degrees. Does everyone see why? If this is 150 degrees right here, then this angle right here is 30 degrees. That's why we were doing reference angles. Okay? Because that angle is the same thing as that 30 degree angle. 30 degrees is the same thing. That 30 degree reference angle is the same thing as 150 degrees. So likewise, if I said, now we found this to be negative square root of 3 over 2, comma 1/2, right? So if I asked you, what is the cosine of 150 degrees, it's the same thing as the cosine of 30 degrees. You understand? Because those coordinates tell you that cosine and sine. All right? So 135 degrees, that's the same thing as the 45 degree angle. And 120 degrees, that's the same thing as the 60 degree angle. Because that's what their reference angles are. Okay? Any questions? Now, you also need to know that 30 degrees is the same thing as pi over 6. So if it asked you, what is the sine of pi over 6? It's 1/2. What is the cosine of pi over 6? It's square root of 3 over 2. Okay? Okay, so that worksheet I just gave you has the unit circle on the right with everything all filled out. And then, on the left. No, on the right. And then on the left-hand side, you have to answer those questions. Okay? You were answering these questions before, and you were having to draw a right triangle every single time and figure out whether it was a 30, 60, 90. Okay? You were having to figure that out. What you're going to do now is let's look at this one. Now, this is not on your sheet. Sine of 2 pi over 3. So you have to take your unit circle, find 2 pi over 3, and then tell me what is the value of the sine. So here's 2 pi over 3, right here. Okay, that's the same thing as 120 degrees. And remember, it goes cosine, sine. Those are my coordinates. So if I want to know the sine of 2 pi over 3, it is square root of 3 over 2. Because this is cosine and this is sine. Okay? That's it. So let's do cosine. Let's finish these. So make sure everybody has a good understanding. Let's do cosine of pi over 6. Cosine is square root of 3 over 2. Cosine of 7 pi over 6. So here's 7 pi over 6. It's cosine the first one or the second one? For cosine the first one. This is cosine. Cosine, sine. Think the C comes before S in the alphabet. Maybe that'll help. So cosine is negative square root of 3 over 2. Sine of pi over 2. Find pi over 2. What degree is pi over 2? 90. This is pi over 2. Cosine sine, what is it? 1. Sine of pi. What degree is pi? Good, 180. What sine? 0. Cosine of 5 pi over 3. God bless you. Find 5 pi over 3. Tell me what degree is that? What's the degree? 5 pi over 3 is how many degrees? 300 degrees. It's right here. And cosine is what? 1/2. So the unit circle is a very handy tool. So instead of you having to figure out the reference angle, draw the triangle, figure out what quadrant it's in, this is all done for you, all in one place. That's a lot of information in one place. Okay?